Hi friends, yeah, we already discussed about the history of Kubernetes and why it is used. So now I am going to tell you the advantages of Kubernetes. By showing the Docker and explaining the Docker how it will work, I will explain you how the Kubernetes is advanced when comparing to the Docker. So for that I am going to create one. I am going to show you by drawing. So I am opening Paint here, MS Paint. So first, let's say we have a server. Okay, we have a server, and over the server I am going to create one, or sorry, I am going to install the Docker. Over the server I install the Docker, and then what I need to do is here I am going to create the containers. So after installing the Docker, I am just creating the containers here. 1 2 and 3. Okay, so let's say here, so we already discussed about microservices, right? So we are doing now the microservices, means we are following now the microservices method. So that's why we have created containers here. Inside of one server we installed Docker, and then we are creating the container, Docker containers. Okay, so let's say this server has two CPU, and 4 GB of RAM. Okay, so this server, right? So here this is microservice. Let's say I'm going to talk about the ebook. Okay, ebook, yeah, we'll take ebook. If you are taking ebook app or website, there is different modules will be there, like user accounts, where we can register or login, and then inventory, that is list of books, and then payment, it may be for rental, or it may be for to buy the book, and then shipping or shipment. Okay, so these modules we will take. We have now 4 modules here in the ebook app. So now also I have 2 CPU and 4 GB RAM. So now I am going to deploy user account here, users in one container, and inventory in another container, and payment in another container. So let's say here I am using 0.5 CPU and 1 GB RAM. The same I am going to use here also, 0.5 and then 1 GB. Same like that here, 0.5 and 1 GB RAM. Okay, so here the another modules is missing. Another module shipment is missing. So here I can able to create only 3 container. Why? Because the server CPU is 2 and RAM is 4 GB. So I am using 0.5 CPU for each. So almost 1.5 CPU is over. So 5 remaining 5 CPU will be 0.5 will be used by server. The same like that for 1 GB each, almost 3 GB is done for each container. So remaining 1 GB will be used by server. So if you are going to deploy another container here, it will not allow you. So here I am going to create another server. I am going to create another server here. Okay, and over to that I am going to install Docker, again same. Then I will create the container for shipment. Okay, so now still we didn't use our Kubernetes, right? We are using Docker. So to sync two servers, which means here in one server 3 containers has been created, in another server 1 container has been created. So here if you want to sync the two servers, two physical servers or two different servers, um, it is not possible actually. But to combine all this module within the server, it is possible. So for that only, to combine more than one container which is in same server, for that we will use the Docker Compose or Docker Swarm. But actually this technology will not allow us to sync two different servers. So that is the problem here. So now to overcome this, we are using the Kubernetes. So whenever we are using the Kubernetes, the container will be installed under pods, Kubernetes pods, but the each means each Kubernetes means each pod or container will be maybe in different server or in same server. If it is in different server, the Kubernetes will have uh, capability to sync the servers. Okay, so that is the advantages of Kubernetes here. So the Kubernetes will work like client server, like master slave model. Okay, so in that case I will show you. So see here, and this is the Kubernetes architecture. Okay, in this case, as I said already, it will work as a master slave architecture. Okay, in that method. So here whenever you are installing a Kubernetes, it will create one master node and it will create the worker nodes also. In the master node only the Kubernetes will be active. In worker node only the parts will be created, and under the parts containers will be created. So this is how it will work. So let me explain you the architecture first. So you can see here master node is there, worker node is there. In master node you can see these many modules will be there, different kubectl, API server, controller manager, scheduler, etc. Here in kubectl we will write one YAML script. Once it is completed, we will execute that YAML script. So then what it will do, it will connect with the API server. Then API server will be connect with the controller manager. This controller manager will check whether the which means which worker node is having healthy condition, means it will check which worker node is healthy. Then once it is found the healthy worker node, it will assign to the scheduler. So after that the scheduler will deploy the container on the healthy worker node under the pod. Okay, this is how it will work. So this etcd, actually this is etcd. Here I had done typo error. So this is having all the configuration of Kubernetes. Okay, and then you can see here kubectl. This kubectl will create a link between the your worker node and master node. If anything issue with this kubectl, then the master node will show you this worker node as failed one, because there is no connection. It will not allow you to deploy any container under the worker node which is where the kubectl is not working properly. Okay, fine. So in next slides we will talk about Kubernetes installation.